So in today's video, we're going to see how we can use a router as a DHCP server and provide dynamic IPs to our VLANs that we created in our last video. We have already seen how we can provide IPs to our systems through a DHCP server that was running on a router, but that was under a scenario in which we were only running a single VLAN. So since in our previous video we made different VLANs that were namely VLAN 10, 20 and 30. The purpose of this video would be to assign IPs that would be dynamic in nature, and also each VLAN will be using a different network ID. In this exercise, we will be using the 10.0 network ID for VLAN 10, the 20.0 VLAN ID for VLAN 20, and 30.0 network ID for VLAN 30. So first we need a router. So let's pick up our router, and then we will need to connect this router. So I'm using the last fast Ethernet port to connect to fast Ethernet 0. So the approach that we will be using in today's video will be router agnostic, in which we create sub interfaces on our router. These are virtual interfaces that are running against our original physical interface, that in this case is fast Ethernet 00. So we will be making virtual sub interfaces of this fast Ethernet 0/0 interface, and we will be using those interfaces to handle the traffic on these VLANs. Okay, in this case that traffic would be the DHCP server that will be running, and it will provide dynamic IPs to our VLANs. So let's start, and the first thing that we will be doing is we will be going into our switch, and we will be changing the fast Ethernet 0/24 port status to trunk, and that means the mode of that interface will be trunk mode. If you remember, we used access port on all these different clients that were connected to our certain VLANs. So when we are using access mode, that interface can carry traffic for only a certain VLAN. And when we are using a trunk mode, that interface can carry traffic for multiple VLANs. So since this link will be carrying all the traffic for VLAN 10, VLAN 20 and VLAN 30, so that's why we are giving this interface the mode trunk. Okay, so the command is very easy, as you remember: switch mode and trunk. So that's all, and let's write. So the next step is go to the CLI, or the router CLI, and first let's get the physical link up. Okay, so if we do not do that and we configure all the sub interfaces, the configuration won't work. Okay, so for the configuration to work, we need to have the physical link that is connecting our router and our switch up. Okay, so since we did that, let's jump to configuring the sub interfaces. So how you configure the sub interface is, for example, when configuring sub interfaces for FA0/0, so we will be given the command FA0/0, and then we will be placing a dot and then a number to signify our sub interface. So it can be any number, but to keep the symmetry, since I'm using VLANs 10, 20 and 30, I will be giving the same number as the VLAN ID. Okay, so since this interface, I'm planning to use this interface for VLAN 10, I have given the sub interface number 0/0.10. Okay, so when we are configuring sub interfaces, we have to provide encapsulation before providing the IP address, and that encapsulation is .1q, and at the end we have to provide the ID, the VLAN ID of the VLAN that this sub interfaces will be providing services to. So since we are using this for VLAN 10, so we have given the ID 10 at the end. Next is IP address, and since we know that every LAN has a gateway, a default gateway, and that is the interface that is connecting the router's interface that is connecting it to the VLAN. So since this will be the interface that will be connecting the VLAN 10 traffic to the router, so we are going to give the IP 10.1. Since this VLAN will be using 10.0 network ID, so since this will be the default gateway, we are using the 10.1, the very first IP, as the default gateway, and then the network subnet mask, we're using the class C subnet mask, and that's all. Okay, so let's go towards the second, that is 0.20, the second sub interface, and same way encapsulation that is necessary, and then the VLAN ID, that is VLAN 20, then IP address, and the same way 20.1 will be used here, since this will be the default gateway for VLAN 20, and then subnet mask, and same way let's go to the third sub interface. State is already up since we already upped the FA00 physical interface. So okay, so let's encapsulation .1q and VLAN 30's ID, and then IP address 192.168.30.1, and then the subnet mask. Okay, so the sub interface configuration is complete. The next step is to configure the DHCP server, and the pool name will be the network ID that I will be using. So since the first pool will be 10.0, so I am giving it the name 10.0, and the network that we will be running is 192.168.10.0, and the subnet mask, and the default gateway. The command for default gateway is default rotor, as we have already seen in our previous videos. So let's give the IP address 10.1. so keep in mind the command that we used earlier, that was the network address, since we used 10.0, but this is the default gateway, so here we will be using the IP, okay, not the network ID. And then the DNS server, we are using the Google's DNS server. Okay, so there you go. This is the first pool. So let's configure the second pool, that is 20.0. sorry, and yeah, so the network will be 192.168.20.0. 255.255.255.0 would be the subnet ID, and the default gateway would be 192.168.20.1, and the DNS would be 8.8.8.8. okay, so let's go towards this third 30.0 pool, and the network would be 192.168.30.0. 255.255.255.0, and default gateway would be 192.168.30.1, and the DNS would be 8.8.8.8. okay, so the pool configuration is okay. Let's write the configuration. If you go for show run, we can see that there are 3 pools that are running. So if we didn't make any mistake, when we switch from static to DHCP, we will be getting a IP. Yeah, there you go. 10.3 for VLAN 10, since we use the network ID 10. And there you go. This would be 10.4. And let's go towards the second VLAN. This should have a 20 dot, yeah, 20.3 is for the first client. And let's change from static to DHCP, and yeah, 20.4 for the second. Let's check for the VLAN 30 and from static to DHCP, and yeah, 30.4 for the first one, and 30.5 for the second one, and 30.6 for the third one. So as you can see, we have successfully configured DHCP for all VLANs, and every VLAN is running their own network ID. So let's check by getting a ping 192.168. For example, 10.3 is the first, so let's try it. And yeah, we have a successful IP. Let's try for 20.3. Another benefit of using a router as a DHCP server is we get inter-VLAN routing by default, since as we know that whenever we are running different network IDs, if we want to communicate between different network IDs, we have to have a router present. So since we're using a router as a DHCP server, it automatically provides us the inter-VLAN routing functionality. So that's why we can also ping the 20.3 or the second VLAN's PC, and same way we can also ping the third VLAN's PC. So that's all for now. This is how you can configure DHCP in a multi-VLAN environment. So until next time, take care.